Dear students, welcome to the lecture series on the topic Engineering Graphics. So today we are going to discuss about applications of the sections of the solids. I am Dr. AIP Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now the first case that we are going to pick up today is regarding the orientation of the section plane, which will be parallel to the horizontal plane and perpendicular to the vertical plane. So here we can see that we are having a cutting plane or a section plane. This cutting plane happens to be parallel to the horizontal plane, and this cutting plane is perpendicular to the vertical plane. Now we are going to have different examples over here. Just see, here we have a cylinder, and this cylinder is being cut by a cutting plane which is a horizontal section plane. That is, it is parallel to horizontal plane, and this cutting plane is perpendicular to the vertical plane. And the arrows which are indicated over here, so they are going to define the position or the orientation from which we are going to look at this particular cut solid. So this portion of the solid will be discarded, whereas the remaining portion of the solid will be left out after the sectioning over there. And the true shape of this section will be available on the horizontal plane, because the cutting plane happens to be parallel to the horizontal plane. So whatever cut section will be available after the cutting or the sectioning of the solid, so this sectioned surface will also be parallel to the horizontal plane. And since the surface happens to be parallel to HP, so the true shape of the surface will be available on the horizontal plane and in the top view. So here we have another example. You can see here we have a square pyramid which has been cut by again a horizontal section plane. Now once this square pyramid is cut by a horizontal section plane, so once again you can see that the cut section which we have obtained, this is again parallel to the HP or the base of the solid. So the true shape of this cut section will be available in the top view, and this is the remainder solid which will be available, and this is called frustum of the square pyramid that we have been able to obtain. So whenever a solid is cut by a cutting plane parallel to its base, so the solid which is left out, it is called frustum of the solid. Now this is the problem we are going to discuss today, that we have got a pentagonal pyramid with us, and this pentagonal pyramid has been cut by once again a horizontal section plane. And once you cut the solid, or that is the pentagonal pyramid with this horizontal section plane, so this upper portion we are going to discard, and this remainder solid will be left to us. That is, this will be again frustum of the pentagonal pyramid, and the true shape of this cut section will be available in the top view onto the horizontal plane. So this is what we are intending to get over here, right? So we are going to discuss this entire problem in a while, right? But we need to understand over here that whenever a solid is cut by a cutting plane which is parallel to horizontal plane and perpendicular to the vertical plane, so the true shape will be available in the top view, right? And another thing we need to understand over here, that since this solid is being cut at all the generators over here, you see these are all the 5 slant edges. So the POIs, that is the points of intersection, which will be obtained over here will be equal to N. N means number of edges of the base or number of corners of the base over here. So since you can see there are 5 slant edges for this pentagonal pyramid, and all the 5 slant edges, they have been cut. So POIs will be equal to N, that is equal to number of edges of the base over there. Now let us read out the statement and work out the appropriate orientation of this pentagonal shape or the shape of the base onto the horizontal plane. So let us read out the statement. A right regular pentagonal pyramid of base side 30 millimeter and length of axis 60 millimeter is resting on the horizontal plane with one of its base edges perpendicular to the vertical plane. Now we have been provided with this data that one of the base edges happens to be perpendicular to the vertical plane. So if we draw this particular orientation of the pentagon in the top view, that is below the XY reference line, so none of the base edges, they will be perpendicular to the vertical plane or the XY reference line. So this is not the orientation of the pentagonal pyramid that we are going to pick up for this problem. So the correct orientation of the pentagonal base shape of the pyramid will be this one over there. So next, a section plane which is perpendicular to the vertical plane and parallel to the horizontal plane, it cuts the solid meeting the axis at a point 35 millimeter above the base. That is, this section plane is located 35 millimeter from the horizontal plane, because this solid is resting onto the horizontal plane. So from the HP, that is from the base of this particular pyramid, you move 35 millimeter upwards along the axis. Now your cutting plane will be passing through the axis at a point 35 mm above its base, that is 35 mm above the horizontal plane. So we are required to draw the front view and the sectional top view of this cut solid over there. So let us start working out the projections of the solid first of all. Now here we get XY line. Now as we have discussed that the true orientation of this pentagonal pyramid is such that one of the edge of this particular pentagonal pyramid happens to be perpendicular to the vertical plane. So this data has been provided to us, a section that is with one of its base edges perpendicular to the vertical plane. So here we have one of the base edge of the pentagon, it is lying perpendicular to the vertical plane or the XY reference line. Now since this is a pentagonal pyramid which is resting onto the horizontal plane, so the true shape of the base of this pentagonal pyramid, it is a pentagon shape and it will be obtained onto the horizontal plane in the top view. So we are going to draw it below the XY reference line. So having drawn this pentagon, now we need to work out the axis point. So in order to obtain the axis point, we need to draw the perpendicular projectors from every corner which will be meeting the bisector of the opposite edge over there. So this is the bisector point of the opposite side or the edge of the pentagon which is opposite to this corner. Similarly, from this corner we drop a perpendicular onto the bisector of the opposite edge. Similarly, you can drop all the 5 perpendiculars over there, right? So from all the corners we need to draw perpendiculars onto each of the opposite edges of the pentagon over there, and then this is the point of intersection of all these bisectors, and this point we are going to label as axis point. And having located this axis point, now we need to join this axis point with all the corners over there. All the corners, they will be joined. Why they will be joined? Because you see all the slant edges, because these are the lines which are going to represent the location of the slant edges over there. So these are the slant edges of the pentagonal pyramid. So here you get O and O1. So O is the axis point of the apex and O1 is the axis point corresponding to the base. So having located this axis point, you see we have joined all this apex point with the base point. So these lengths, these are the apparent lengths for all the slant edges of this particular pentagonal pyramid over there. Another thing, we have joined all these slant edges not with dark lines, that is the object lines. We have joined all these slant edges with 2H lines over there or the construction lines over there. Why? Because we know that certain portion of these slant edges, they will be cut by the cutting plane over there. So this cutting plane is going to take away, you see this portion of the slant edge, this portion of the slant edge, this portion and this portion of the slant edge will be discarded away. That is because this top portion is going to be discarded away. So now this solid is no longer available with us. We are left with only frustum of the pentagonal pyramid. And since we are left with frustum of the pentagonal pyramid, so it won't have these portions of the slant edges in the final projections of the object which we are going to obtain onto the top plane. So that is why we have drawn all these slant edges using 2H pencil line or using the construction lines over there. So having completed the initial top view of this pentagonal pyramid, and we have also obtained the axis, now we need to draw the front view. And before we start drawing the front view, you see many students, they often make this mistake that they are going to join these two ends, that is these two corners over there, B and E, and they will be just lifting this up and mark the axis height over there. No, the axis will be lying always, as I have been discussing this number of times. You join these two corners and you will find that axis point lies slightly below this particular construction line which is going to join these two corners. So we have just discussed how to obtain the axis line. Having obtained the axis line, now I am going to draw the axis over there. Just see, this is my axis line, and once I show the axis representation, just see, this is the representation of the axis over there. It is a chain line which is having large and small sections over there. Now I need to measure this axis length is equal to 60 millimeter. So the length of the axis is given to me as 60 millimeters. So just see, O1 dash point is automatically located once I draw these projections in the front view, and the top point O dash, it will be located since I am going to measure the axis height is equal to 60 millimeter over here. So now the front view projections at the base, they have been worked out. That is the you draw the projector through A, you get the projection A dash onto the vertical plane, that is onto the horizontal plane over here. That is because the base is lying on the HP. So on the XY line in the vertical plane, I am going to get the projection for A dash. I am going to draw the projector through B and E. So B dash and E dash points will be located onto the ground basically, that is in the vertical plane. Similarly, you draw the horizontal projector through C and D. So C dash and D dash are the front view of these projector points C and D, which are obtained once again on the XY line. So now we have obtained all the projections of the base in the front view, that is onto the vertical plane, and the apex point has also been evaluated. Now we are going to once again join O dash with all the points of the base, that is O dash A dash, O dash B dash, O dash C dash, O dash D dash, and O dash E dash will be joined over there. And here we need to remember projections of O dash E dash, they will be dotted because it is on the back side, but they are being superseded by projections of the OB, which are going to be dark line, and they will be represented by the object line. So this object line is going to overshadow this hidden line over there. So ultimately this will be drawn dark. Similarly, projections for slant edge O dash D dash, they have to be dotted because it is lying on the back side, but again they will be overshadowed by the object line, that is dark projections corresponding to the slant edge OC. So that is why this has also been drawn dark or the solid line. But why we have not completed this darkness over there? Because I have to cut this solid in a way that it has been given to me that there is a plane which is perpendicular to VP and parallel to HP. It is this plane. There is a plane which is perpendicular to VP and parallel to HP, which is going to cut the solid at a point 35 millimeter from the base. So 35 millimeter above the base, I am going to mark a point over here, and once I mark a point, now my cutting plane will be located over here. So this is the representation of a cutting plane, and in the cutting plane the two ends, they have to be dark So that is why you see I have darkened the end points over here. And after darkening this, now I have come to know that this portion, that is a shorter, you see, pentagonal pyramid was obtained. So this has been discarded. It has been thrown out. And then I am left with the frustum of the pentagonal pyramid. So these are the edges which are left with me. Just see, this is left with me, this is left with me, and this is also left with me. So now I am going to darken this. So we call this plane as, you see, AHP, that is, it is the auxiliary horizontal plane, because it is parallel to the horizontal plane over there. Now I can darken this section, first slant edge, which was O dash A dash, which was cut over here. The naming of these points of intersections we are going to do in a while, but initially we need to darken the remainder portion of the solid which is available with us. You see, this portion is available with us, this portion is available with us, and this portion is available with us. Similarly, I can darken this. So the slant edges O dash, B dash and O dash, E dash, they have been cut at this particular point of intersection. Similarly, my cutting plane is cutting these slant edges O dash, C dash and O dash, E dash at these 2 points of intersection over there. So now we are going to do the naming of these points of intersection. So please see how many points of intersection are there. O dash, A dash is being cut over here. I can name this point as 1 dash. O dash, B dash slant edge has been cut over here. I will name it as 2 dash. O dash, C dash slant edge has been cut by my cutting plane at this point. So this point corresponding to C, this is the third POI, so I'll name this as 3 dash. Similarly, O dash, D dash, you see slant edge has been cut by the cutting plane at this point, so the name of this point will also be 4 dash. And finally, the slant edge O dash, E dash has been cut by the cutting plane at this point, so the name of this point will be 5 dash. So 1 dash, 2 dash, 3 dash, 4 dash and 5 dash. So these are the 5 points of intersection which are available to me in the front view. Now these 5 points of intersection, now you see I have drawn the arrows over there. Drawing the arrows mean now this portion is no longer existing in the solid. So I am going to look at the cut section. I am interested in the cut section because I know the true shape of the original solid, which was the pentagon, that is the base of the solid was pentagon, which I already know. Now I want to know the true shape of these points of intersection, that is the edges which are going to join. Just see, these are the edges which are going to join these points of intersection over there. So let us start working out that, and n number of points of intersections will be there. That is, since all these slant edges they have been cut by the cutting plane, so the number of points of intersection will be equal to 5, that is edges of the base over there. Now let us start with the evaluation of the top view of these points of intersection. So point number 1, you see, this is the first point of intersection. So the first point of intersection is lying on O dash A dash. So I am going to number this point as point 1. So please see, this 1 dash lies on O dash A dash. Now I am going to bring this point down. Where should I locate it? On the plan line of O1. So just see, this is my plan projection of the slant edge O1. So it was cut by a cutting plane, yielding me a point of intersection 1 dash at this location. So just like any other projections of 1 dash and 1, they will be lying in a single vertical line. So I am going to draw a construction line or a projector line. Now you see, all projector lines corresponding to the cutting plane I am showing with the help of sky blue lighter line, whereas all others we had drawn with the other colors over there. Just see, so 1 dash I am going to bring it down. So wherever this vertical projector going to intersect OA, that is the top view of the slant edge OA. So I get this intersection point as 1 point over here. So 1 dash, it is the front view of the first POI. This is the top view of the first POI. Now we move on to the second POI. Second POI is that is point 2 dash. So 2 dash point lies on the slant edge, that is O dash B dash. Now it will be intersected over here. I obtain the point 2 dash. Now from 2 dash I will be bringing a vertical projector to intersect the top view of the slant edge, that is OB. Just see, this was lying on point 2 dash was lying on front view of the slant edge O dash B dash. Now this point 2 dash will be projected downwards. Just check this out till it intersects the vertical projection for the slant edge OB. So wherever this intersection is obtained, point 2 will be obtained. Similarly, because OB is going to overshadow OE, so obviously point 5 dash is going to lie upon the slant edge, that is O dash E dash. So O dash E dash is lying again at the same place. So O dash E dash has also been cut by the cutting plane. So since E is the fifth point, so corresponding to E, the numeral value has been given assigned as 5 dash over here. So O dash E dash has been cut by the cutting plane at the point 5 dash. So once again, from 5 dash I will be bringing the vertical projector till it intersects the top view of the slant edge, which is O and E over here. So it intersects the slant edge OE at point 5 over here. So point 2 and point 5 they have been located. Next, OC, O dash, C dash and O dash, D dash, they have been cut by the cutting plane at this particular point of intersection. So corresponding to O dash, C dash, the name of the point of intersection is 3 dash. Now I will be bringing this vertical projector to meet the top view of the slant edge, that is OC. Just see, this is O dash, C dash. So 3 dash point lies on O dash, C dash. So point 3 will be lying on top view, that is OC. So from 3 dash you draw the vertical projection. Wherever it intersects the top view or the plan projection for this slant edge, that is OC, you get point 3. Similarly, point 4 dash is also located here. So from 4 dash, which was lying on the slant edge O dash D dash. So once again I am going to draw the vertical projector till it meets the plan projector line of the slant edge, that is OD. So it cuts OD at this point. So point 4 is also located. So just see, point POI 1 top view has been located, POI 2 top view has been located, POI 3, 4 and 5, all these top views they have been located for 5 POIs, and now front views they were already located. Now we are going to put dots over here which are going to indicate the points of the intersections, and now we can join all these POIs. So once we join all these POIs, now you can see these edges which are formed by joining all the POIs, they have been evaluated, and after joining these edges, you see we obtain the true shape of the cut section in the top view. Just see, we have obtained the true shape. Why do we say this is true shape? It is true shape because our cutting plane happened to be parallel to the horizontal plane, and since our cutting plane was parallel to the horizontal plane, the cut section which has been obtained over here or over here, this is also parallel to HP. So its projection on the horizontal plane will provide us with the true shape of this cut section. So now in any case, sectioning has to be provided with the help of, it has to be labeled with the help of the hatching line, and hatching lines are, once again, they are equi-spaced lighter lines which are drawn at an angle of 45 degree with respect to this reference plane, which is our XY reference plane. So the intermediate reference plane is XY. So these hatching lines will be drawn by 2H pencil. These will be the equi-spaced lines at an angle of 45 degree with respect to XY reference line. And now having obtained this, now I need to join, you see, the slant edges, whatever the remainder portion of the slant edges they are left, I need to do the joining of all these POIs with the corresponding base point. So POI 1 has been joined with base corner A, POI 2 has been joined with base corner 2, POI 3 has been joined with base corner 3, POI 4 has been joined with base corner D, and POI 5 has been joined with base corner E. So this way I have been able to complete the top view of the frustum of the pentagonal pyramid. This is the front view of the frustum of the pentagonal pyramid, right? And I am also going to label this as a true shape, because otherwise I would have had this cutting plane been inclined to this horizontal plane, then I would have said that this is the sectioned top view. It would have become the apparent shape. But since my cutting plane is parallel to HP, so the shape which is obtained in the top view corresponding to the cut section, this will be my true shape. So there are two names for this. First name is true shape, and the actual technical name is sectioned top view, because this portion has been cut or sectioned. So it is the sectioned top view of this cut section over here, right? So if the surface would have been inclined, we would have said this is the apparent shape. But since this cutting plane is parallel, so this section top view which is obtained on the horizontal plane will depict the true shape of the cut section. So this is all about the discussion that we wanted to make regarding the sections of the solid when our section plane happened to be parallel to the horizontal plane and perpendicular to the vertical plane. We'll be continuing with the further discussion on few more problems regarding the section of solids in the subsequent lectures in this lecture series. So thank you very much. Thanks a lot. Thank you.